Hi everybody, this is Mrs. Dinkelman, and this is the notes for lesson 3.2, chain rule with exponential and logs, including with bases other than e, although we'll focus mostly on the ones that have bases that are e related. So Gary puts a lot of information. Gary, again, is the guy who writes the curriculum. What I want you to glom onto is just what the derivative of e to the x and natural log of x are going to be. And the other stuff is just kind of talking us through chain rule a little bit. So we'll just remember chain rule and we won't have to think about this u, although I know why he does that when we get to kind of reversing this process. So the next little bit there, again, we'll make sure that you highlight that the derivative of e to the x is e to the x and that the derivative of natural log is 1 over x. And then there's a little explanation for y there, okay? So now let's go ahead and look at, make sure we write down the derivative of a to the x. So if a is a number, even if it's e, technically it fits this formula here, but if it's like a 2 to the x or a 3 to the x, then our derivative is just 3 to the x times ln of 3. And then if we have a log other than natural log, we're going to use this formula. Again, I'm going to ignore that u stuff because we know we have to do chain rule, and we will make sure that we do it when necessary. So make sure that you have those two written down. So for log base a, it's 1 over x times ln a there in the denominator. And for the derivative of a to the x, it's a to the x times natural log of a. Again, it definitely fits. If we do the, think about log base e or e to the x, it still fits that situation. There's a reason in calculus we really like e to the x and natural log of x because their derivatives are a little bit easier, okay? Okay, so let's just walk through some examples and take the derivatives and talk through chain rule a little bit as we go here. So the way I like to say chain rule with e to the x's is I know the derivative of e to the x is just e to the x, so that's kind of like doing the derivative of the outside function, that's the e. So I say it's e to the stuff, and then because of chain rule we also have to do times the derivative of the stuff. Okay, so it's that exponent that we have to remember to also take the derivative of later. Again, I'm going to kind of ignore this for just a second. For g prime of x here, normally it would be 1 over x like we learned earlier, but it's not just an x, it's a 3x. And then the derivative of the 3x, because of chain rule, is 3. So 3 over 3x, oh guess what, that still becomes x. The way I like to say natural logs derivatives is 1 over the stuff times the derivative of the stuff because of chain rule. All right, Gary didn't leave me too much room here for 3 and 4, so I guess I'll do them off to the side here. Actually, that's just the same. Oh, he's giving us another option there to remember that technically our multiplication in logs is really an addition, and so the derivative of natural log of 3 becomes 0, and the derivative of natural log becomes 1 over x. So that's another way to do the derivative, although I don't usually do it that way. Okay, we'll do 4 then. So 4, again, thinking about chain rule, y prime here is going to be 1 over the stuff times the derivative of the stuff. So I would probably want to simplify that as far as the answer is concerned, just to write it like this, okay? Okay, number 5, we have to go to product rule and use this new information. So it's going to be first times the derivative of the second plus second times the derivative of the first. Clearly there's a little simplifying we can do in there. Before I start number 6, I kind of want to rewrite this as e to the negative 3t to the negative 1. Okay, so g prime is going to be e to the stuff times the derivative of the stuff, which is going to now be positive 3t to the negative 2. And again, I can simplify that. All right, number 7, again, I'm going to rewrite this one. This is 3 to the v to the 1/2. Kind of running out of space there. I might write it down here. 3 to the v to the 1/2. Okay, so a couple things here. So remember for this one, what we're supposed to do is it's supposed to be the same thing. I'm also supposed to sneak in a natural log of 3 because this is not an e to the x. And then the derivative of the v to the 1/2 would be, again, that is because of chain rule, I have to do all that. So let me recap. the derivative of like a base to a power, we get the same repeat, we get natural log of the base, and then this one, that part is because of chain rule. Okay, example 8 here, so the graph of natural log, and I kind of wish they didn't make me work too hard at finding this, but I know natural log of 1 is 0, so natural log looks basically something like this. And then if I get to absolute value x, then I'm allowed to go ahead and just copy this other side. Okay. Let's see, so for the right half of the graph, the absolute value has no effect, okay? But for the left half, when we take this derivative, remember derivative is talking about the slope of the tangent line, so I really should get, I really should be getting a negative 1 over x on that one. So I think he wants us to do this one just to talk about the fact that when we, because of the domain restriction and because of absolute values, this would cause an issue for us. So even looking pictorially, I know this should be a negative 1 over x, okay? Okay, so he's just reminding us that we tend to have absolute value bars around the variable with natural log because we don't know if there's some sort of domain restriction, but when we take the derivative, we're just going to ignore those. So this one, and I wish he hadn't used y's, but that's okay. So the derivative is going to be 1 over the stuff times the derivative of the stuff, and again, I probably would rewrite that for my own benefit, just 1 over the other. Okay, so down to example 10. One of the things that we can do to make our life a little bit easier in finding the derivatives of natural logs is use their properties. Because if I try to do 1 over the stuff and then do the derivative of the stuff here, I'm going to have to do product rule, chain rule, quotient rule, etc. So let's rewrite this logarithm. So remember that addition in logarithms, or multiplication is really addition. I'm also going to write that square root as having an exponent because we know something happens there. And then division is really subtraction, and that's all because really logs are talking about exponents. So the next thing that gets to happen is that 1/2 can actually just pop down here and become a coefficient, and that will make it so we don't have to do chain rule there. So now our derivative for the first part is just 1 over x. The second one, we have a 1/2 there, so let's make sure we have that there. And then 1 over the stuff times the derivative of the stuff, so we can see that's going to cancel. And then 1 over the stuff times the derivative of the stuff, and then you decide how much you want to simplify there. All right, example 11. So they just want to remind us about what y prime looks like. So we do 1 over the stuff times the derivative of the stuff, but the extra piece here is that we have a natural log of that base, so a natural log of 2. So now if we're trying to plug in a 2, I'm going to move this 2x right here up to the numerator there. So 2 times 2 is going to be 4. 2 squared plus 1 is 5. And then I also have a natural log of 2. And we can just leave it that way. If you really want to calculate it with the calculator, you're welcome to do that as well. Okay, so get to the assignment on finding the derivatives of e's and logs.